If the maximum height attained by the ball above the surface of the, then the speed of projection V naught. So what is the basic idea here? So when it is here, the force F1 will act. When the particle is here, V2, the force F2 will act. Can we apply? Net torque is 0. So applying conservation of angular momentum, mv naught r should be equal to mv2 into 3r, or say 4r. Then speed of projection is asking. So we don't know V2. So this will become V2 equal to V naught equal to 4V2. This is one equation. Apply conservation of mechanical energy. These are the routine problems. Mass of Earth, mr should be equal to mv square by 2 minus gmem 4r. Solve these two equations, 1 and 2, get the required answer. And no second thought. Conservation of angular momentum, conservation of mechanical energy. No. The diagram, you should assume it properly. That's all here. Read the question first. How do it will come and strike? I think that particular thing has to be, if falls on the planet making an angle 30 degrees, the line joining the point of impact at center of planet, then is asking what all the conditions. Let me take same diagram. Yeah. Here only. So how the velocity falls on planet making an angle 30 degree with line joining the point of impact and the center of the planet. So can we apply now conservation of angular momentum? This should be equal to mu r should be equal to mv sine 30 into r. Now the angular momentum will be conserved. We don't know v, so v you can write it as u by 2. V equal to 2u. Expression for u. So I'll apply conservation of energy principle. It is far away, no, initially. This is infinity. Mu square equal to mv square minus g capital M small m by r. Substitute v here, solve for you, you'll get the required answer.